Assalamu alaikum. My name is Aqsa, roll number 21TE08. Today we are diving into the fascinating world of digital signal processing right there. In this lab, I have got a bunch of tasks lined up that showcase the magic of digital signal processing and how it plays a crucial role in various applications.
Of this lab is to representation of unit impulse function and unit step function, making unit step function using unit impulse sequence and making an arbitrary signal out of delta. In task 1, representation of unit impulse function in MATLAB, open editor and write the code snippet in the same file with function name, that is in the case is unit sequence. So create a function x and n that is equal to impulse sequence n0, n1 and n2. N is equals to n1 ratio n2. So this line creates a vector n containing the vector from n1 to n2, and x is equals to n minus n0. Now you can use this unit impulse function in any script file or command window, and the resulting output is this. Task 2, representation of unit step function in MATLAB. Open the editor and write the code snippet in the following and save the file function name as step sequence. So same, create a function x of n that is equals to step sequence n0, n1 and n2. So this line also creates a vector n containing the vectors from n1 to n2. This line represents the range of indices from which the signal can be generated. X is equals to n minus n naught is greater than or equal to 0. So this line generates a signal values x of n based on the unit step function. The expression n minus n0 is greater than or equal to 0 evaluates to 1 true and n is greater than or equals to n0 and 0 false. Otherwise, this effectively implements the unit step function. Now you can use this unit impulse function in any script file or command window in the following command. The resulting output is this. In the task 3, unit step sequence can be constructed by add shift impulse sequence, and this is the formula. Use unit step sequence of task 1 and construction unit step sequence. Is it possible to construct the shifted version of unit step sequence by summation of deltas? If yes, then what is required to do so? Use command pulse and hold off and hold on. So in this code, generate a function name as unit step sequence is equals to unit step delta, where delta is equals to zeros 1 by n, initializes a zero vector delta of length n. This is the input sequence that will be used to generate the input step unit. Unit step sequence is equals to zero size delta. Initializes the unit step sequence with 0 having the same size as the input sequence delta. Figure creates a new figure for plotting. Subplot 2 1 1 divides the figure into two subplots, and the first subplot is selected for the plotting the input sequence delta. Stem 0 ratio n minus 1 delta x line width 1.5 plots the input sequence delta using red stems with a specified line width, and subplot 1 to 1, this is the subplot 212, select the second subplot for plotting the evolving unit step sequence. Hold on allows multiple plots to be displayed on the same subplot. The for loop iterates over time step from 1 to n and each step. And this is the command window, and the resulting output is this, the unit step sequence. In task 4, it is given an arbitrary signal can be represented by unit impulse sequence, and the formula is given. Create a function unit step sequence is equals to generate unit step delta, where delta is equals to unit step sequence. task 4 is same as task 5 and the resulting output of task 4 is this signal. This is the generated signals. In task 5, splitting a signal into even and odd parts. If if an imaginary x is equals to 0, checks if the input sequence x has any non-zero imaginary parts. If it does, the function throws an error since it is designed to handle only one sequence. M is equals to minus flip n. It creates a mirrored version of the time indices n. This is used for the decomposition. M1 is equals to minimum mn and M2 is equals to maximum Mn, where M is equals to M1 ratio M2. It determines the range of indices over the decomposition will be performed and adjust the sequence of X to match the extended range determined by the M. X is equals to 0.5 and this line computes the even and odd parts of the sequence. The now displays the result for clarity. Note that the displacement section is added for the educational purposes. And the command window, this is the command window, this is the resulting output. In task number 6, impulse train can be used for sampling of continuous time signal for following continuous time signal. In this code, given t is the time vector and the range of t is 0 to 2. The frequency is 1 and ct continuous time signal is equals to cos f2 pi or t. Subplot, give them a title, the label, and x-axis and y-axis, and the resulting output. The resulting continuous time signal output is this. Thank you so much for watching my video.